You're sitting in a Class 11 physics exam. You've derived the dimensions perfectly, but when you write your final answer, you lose points. This usually happens because the terms dimensional formula and dimensional equation are used interchangeably, even though they represent two different things. To a beginner, writing brackets and letters looks the same regardless of the label. However, physicists require precision in how we frame these mathematical relationships. The confusion is understandable. Both concepts rely on the same bracketed base quantities, mass, length, and time, represented as m, l, and t. The visual difference is so subtle that it's easy to overlook. To avoid this trap, we have to distinguish between a standalone expression and a complete equality. In physics, the way we structure a relationship is just as important as the variables contained within it. A dimensional formula is the expression that shows how and which of the base quantities represent the dimensions of a physical quantity. Think of it as a structural blueprint. It's a descriptive expression identifying a quantity's nature, but it lacks a subject and an equal sign. Take the volume of an object. Being three lengths multiplied together, it's written as bracket m0, l3, t0. This blueprint adapts. Speed is length over time, m0, l, t minus 1. Force requires mass and acceleration, m, l, t minus 2. A dimensional formula provides a nature-based description, but it is not yet a complete mathematical statement. To turn that description into a statement, we need a declaration. We have to tie the physical quantity's name directly to its dimensional blueprint. This creates a dimensional equation, the full statement obtained by equating a physical quantity symbol with its matching dimensional formula. This requires two additions, the quantity symbol in brackets and an equal sign to bridge them. Now we have finished mathematical sentences. Volume is bracket v equals m0, l3, t0. We do the same for speed, bracket v, and mass density, bracket rho. The equation is the complete sentence of dimensional analysis. It provides a subject, the verb of equality, and a predicate. Use this side-by-side comparison as a mental checklist to keep these terms straight during your next lab or exam. The formula is strictly the right-hand side, the blueprint. The equation is the entire line, the statement of equality. These equations allow us to perform dimensional analysis. By equating the dimensions on both sides of a complex physics relation, we can verify if the math is consistent or if the formula is physically impossible. Always respect these dimensional identities in your intermediate calculations. It ensures your logic remains grounded in the physical reality of the units you use. Think of the equal sign as the link that translates a simple name into its internal physical structure. Mastering the distinction between an expression and a statement allows you to speak the mathematical language of physics with true fluency.